Everybody understands the frustration of getting caught in rush hour traffic, but thanks to multiple engineering disciplines, traffic jams may become a thing of the past. In recent years, major companies have invested numerous resources in producing a self-driving car. If successful, drivers will be able to stop wasting hours stuck in traffic during their daily commute. This has only become possible through collaboration between mechanical, transportation, electrical, and software engineers.
Mechanical engineering is a field of engineering that understands mechanical systems through skills in materials, solid and fluid mechanics, thermodynamics, heat transfer, control, instrumentation, design, and manufacturing. There are two main contributions that mechanical engineers make to the autonomous vehicles. First, the imitation of human drivers, and second, backup safety systems. When developing self-driving cars, there is a need for analyzing the actions of human drivers while they are driving and further translating these actions to autonomous vehicles. Chris Gertis, who has a PhD in mechanical engineering, has been working on autonomous driving systems since the 1990s. He is a prime example of how mechanical engineers contribute to the autonomous vehicle. He claims that drivers process speed and braking by getting a feel for the road through the steering wheel. It is all about friction. Drivers know how much torque to put in the steering wheel. Therefore, in the lab, Gertis and his team have figured out how to calculate friction, which is the capability of the car or its limits, through sensors on the electric power steering system. Their algorithms that drive the car process all of the data from the sensors and arrive at a driving path and commands to the occupant. Integrating those results with vehicle dynamic data will better use an autonomous car's capabilities. For backup systems, mechanical engineers don't simply contribute to the imitation of human actions into the autonomous vehicle. They play an important role in the backup safety systems of the vehicle too. Despite the increasing process and design that is going into the autonomous vehicle, there cannot be a complete reliance upon the systems of the car. This is where mechanical engineers play a large role in the design of the backup of large systems in the vehicle, namely the brake system and the steering system. If the self-driving car is to suffer a failure in any of these areas, the backup systems put in place by mechanical engineers will ensure the safety of any test drivers or other people on the road. As shown on the diagram in this slide, taken from the Google website of the self-driving car, we can see how brake and steering backup systems play an important role in the self-driving car.
Electrical engineering is a field of engineering that generally deals with the study and application of electricity, electronics, and electromagnetism. In order for the self-driving car to be safe and even remotely possible, electrical engineers were tasked to design a detection system with extreme accuracy and precision. LiDAR, which stands for Light Illuminating Detection and Ranging, is a surveying method that measures the distance to a target by illuminating that target with a laser light. Autonomous vehicles, such as the Google self-driving car, use rotating LiDAR detectors to produce extremely high-quality 3D images of its surroundings. LiDAR makes use of an array of 64 laser beams and can produce images up to 200 meters away. Electrical engineers have carefully crafted these LiDAR detectors using emission optics, optical fiber heads, pulse-generating electronics, acquisition and processing electronics, and synchronization systems. The transmitters, or lasers, are single wavelength and polarized. It is a very high-energy laser source. Photomultiplier tubes are an important component of this cutting-edge technology. They are photoemissive devices in which the absorption of a photon results in the emission of an electron. They are extremely sensitive detectors of light in the ultraviolet, visible, and near-infrared ranges. These detectors multiply the current produced by incident light by as much as 100 million times, enabling, for example, individual photons to be detected when the incident flux of light is very low. LiDAR also includes GPS, radar, and high-definition cameras to create the most accurate images possible.
Electrical engineers have worked hard to ensure that self-driving cars can collect the required information about their surroundings, but the cars will need to know how to handle this information. This is where software engineers step in. Software engineers develop the complex software systems used in today's advancing computer technologies, and with emerging technology like self-driving cars, they will certainly have their hands full. The first goal of software engineers is to get the car to interpret the data in a meaningful way. The cars need to be able to recognize objects and identify them based on patterns in things such as shape and movement. At first, this may seem like an impossible task because of the large variety of objects encountered on the road, but Google does have some experience in this type of work. In 2014, Google's team GoogleNet won first place at the ImageNet Large-Scale Visual Recognition Challenge in the classification and detection categories. The key to their success was the use of neural networks created with the disbelief infrastructure, and the software was able to identify objects even when they were slightly obstructed. This leads to improvement in database searching, facial recognition, and more importantly, self-driving cars, because although the program cannot be applied directly, the principles behind it can be. With recognition software in place, the car can categorize the obstacles it encounters, and software engineers can program the car to behave a certain way when it encounters certain objects, yielding to a pedestrian at a sidewalk being an obvious example. With all of this put together, software engineers are able to make the car thoroughly understand its environment. But what about making the environment understand the car? Driving relies heavily on communication with other drivers, and this communication goes beyond the use of turn signals, often including eye contact and the occasional obscene gesture out of your driver's side window. Software engineers need to ensure the car behaves in a way so that its intentions can be understood. Solutions to this include the car inching out into the intersection to indicate it plans on proceeding. Although these are some big problems to overcome for software engineers, they are not the only ones.
There are many environmental challenges a software engineer must overcome when writing code for autonomous vehicles. These include any type of precipitation falling from the sky, which greatly inhibits the LiDAR laser sensors, causing their effective range to be reduced. The droplets also challenge engineers because the code must be able to distinguish between the droplets which the car is allowed to drive through and other objects that the car must yield to. More environmental challenges comprise of factors such as slippery roads and hills. These are difficult because software engineers must be able to integrate code into the car, helping distinguish the difference between ice and a puddle of water, and tell the car how to drive through these conditions safely. In addition, hills pose a challenge because the sensors get pointed at the sky or at the ground, and the sudden change of viewpoint must be adapted to quickly so that the car does not become blind to potential hazards. Along with environmental challenges, the software engineers face more obligations when coding. In the instance of a Tesla crash, a man was killed when the autopilot mode failed to apply the brakes as a semi turned in front of the car. The system failed to recognize the white trailer against the bright spring day background. The crash was caused by a number of factors, but the overall issue was the code of the car failed, and many people wanted to put the engineer at fault. This particular instance is the only known death related to self-driving cars, and on a more positive note, Google's engineers report an accident rate that is significantly lower than human-operated cars. Though software engineers write code designed to avoid accidents altogether, they also include what to do in the event that a collision cannot be avoided. This type of software can help shift the car to impact certain areas in order to protect the driver and others in the vehicle. Unfortunately, this brings up discussion about whether or not it is okay for a computer to decide who gets to survive in the event of an extreme accident. The morality of these issues will change as society continues to accept autonomous machines as the norm.
The way the general public views autonomous cars is critical for its future. Self-driving cars have the potential to improve safety, efficiency, and sustainability. As the average citizen becomes drawn to the industry of a self-driving car, the entire industry itself has the power to completely change and adapt. Since congestion and daily accidents caused by drivers causes delays, money, and an extreme amount of pollution now, the self-driving car can dramatically increase efficiency and therefore increase safety and decrease environmental costs. Self-driving cars have the potential to contain an accurate level of precision, thus reducing energy consumption and pollution levels. Potentially, since the car can drive itself, an individual does not need to know how to drive in order to enjoy the freedom that transportation by car brings. Therefore, a lot more people will be able to enjoy the benefits of self-driving cars, opening up an array of possibilities to a large amount of society, breaking down some social barriers. In the future, a considerable amount of effort will need to be devoted to the legislation regarding self-driving cars. Determining liability during the future possible accidents will be a key part of the legality. The infrastructure itself will need a significant upgrade in order to handle the changes and capacity the self-driving car will bring. Changes at both state and national level need to be addressed. Since this technology is still relatively foreign to the average citizen, many feel uncomfortable with the self-driving car and the technology that it uses and view it as unsafe. As people become more comfortable with the safety, and the demand will become greater, and the barrier that cost currently poses will disappear. Potentially, self-driving cars have the possibility to go beyond the average city road. In the field of agriculture, precision farming can be achieved, thus reducing costs and pollution. However, now autonomous cars still need to address the problem of identifying natural objects the car can and can't drive over when it is off-road.
The self-driving car has the potential to revolutionize transportation in modern society. Engineers are working together from many disciplines to construct a safe, reliable vehicle that is 100% autonomous. Through collaboration and innovation, engineers are hopeful that the self-driving car will one day be the primary method of transportation seen on the roads.